Welcome, everyone. Today, we are looking at Topic 6 in your SS3 Physics series, Atomic Structure and Energy Levels. This topic covers the structure of the atom, the arrangement of electrons, and the energy levels they occupy. This topic often appears in your examinations. You must understand the models, the spectra, and the calculations. Pay close attention. Let us begin. First, let me explain what atomic structure is. Atomic structure refers to the arrangement of particles within an atom. An atom consists of a central nucleus surrounded by electrons. The nucleus contains protons and neutrons. Protons are positively charged. Neutrons have no charge. Electrons are negatively charged. The number of protons determines the element. The number of electrons equals the number of protons in a neutral atom. The electrons occupy specific regions around the nucleus called energy levels, or shells. Understanding atomic structure is essential for understanding chemistry and physics. It is the foundation of modern science. Let us now examine the historical development of atomic models. Now let me explain the historical development of atomic models. The first model was the Dalton model. Dalton proposed that atoms were solid, indivisible spheres. The second model was the Thomson model. Thomson discovered the electron. He proposed the plum pudding model. The atom was a sphere of positive charge with electrons embedded in it. The third model was the Rutherford model. Rutherford performed the gold foil experiment. He discovered the nucleus. He proposed that the atom has a small, dense, positively charged nucleus with electrons orbiting around it. The fourth model was the Bohr model. Bohr proposed that electrons orbit the nucleus in specific energy levels. The fifth model is the quantum mechanical model. This is the modern model. It uses probability clouds to describe electron positions. Understanding these models is essential for understanding atomic structure. Each model built upon the previous one. Now, let me explain the Bohr model of the atom. The Bohr model was proposed by Niels Bohr in 1913. It was a major advancement in understanding atomic structure. Bohr made several key assumptions. First, electrons orbit the nucleus in circular orbits. These orbits are called energy levels or shells. Second, the angular momentum of an electron is quantized. It can only take certain values. Third, electrons do not radiate energy when they are in a fixed orbit. They are in stationary states. Fourth, electrons can jump from one orbit to another. When an electron jumps to a higher orbit, it absorbs energy. When it jumps to a lower orbit, it emits energy. The energy emitted or absorbed is equal to the difference in energy between the two levels. The formula is delta E equals E subscript 2 minus E subscript 1. This energy is emitted as a photon. Understanding the Bohr model is essential for understanding atomic spectra. This is a key concept in atomic physics. Now, let me explain energy levels. Energy levels are the fixed orbits in which electrons revolve around the nucleus. They are also called shells. They are designated by the principal quantum number, n. The lowest energy level is n equals 1. This is the ground state. It is closest to the nucleus. Higher energy levels are n equals 2, n equals 3, and so on. Each energy level can hold a maximum number of electrons. The formula is 2 times n squared. The first energy level can hold 2 electrons. The second can hold 8 electrons. The third can hold 18 electrons. The fourth can hold 32 electrons. Electrons fill the lower energy levels first. This is the Aufbau principle. Understanding energy levels is essential for understanding electron arrangement. This is frequently tested. Now, let me explain the energy of electrons in an atom. The energy of an electron in a hydrogen atom is given by a specific formula. The formula is E subscript n equals negative 13.6 electron volts divided by n squared. Here, E subscript n is the energy of the electron in the nth energy level. N is the principal quantum number. The negative sign indicates that the electron is bound to the nucleus. The energy is 0 when the electron is infinitely far from the nucleus. As n increases, the energy increases. It becomes less negative. The energy difference between levels is given by the formula delta E equals 13.6 times 1 over n subscript 1 squared minus 1 over n subscript 2 squared electron volts. Understanding this formula is essential for calculating energy transitions. This is a common calculation in your examinations. Now let me explain atomic spectra. Atomic spectra are the patterns of light emitted or absorbed by atoms. When electrons jump from higher energy levels to lower energy levels, they emit light. This light has specific wavelengths. This produces an emission spectrum. When electrons jump from lower energy levels to higher energy levels, they absorb light. This produces an absorption spectrum. Each element has a unique spectrum. This is like a fingerprint. It can be used to identify elements. The spectra are discrete lines, not continuous bands. This shows that energy levels are quantized. Understanding atomic spectra is essential for understanding the structure of atoms. This is a key concept in spectroscopy. Now, let me explain the hydrogen spectrum. The hydrogen spectrum is the simplest atomic spectrum. It consists of several series of lines. The Lyman series is in the ultraviolet region. It corresponds to transitions to n equals 1. The Balmer series is in the visible region. It corresponds to transitions to n equals 2. The Paschen series is in the infrared region. It corresponds to transitions to n equals 3. The Brackett series is in the infrared region. It corresponds to transitions to n equals 4. The Punt series is in the infrared region. It corresponds to transitions to n equals 5. The Balmer series is the most important for us. It includes the visible lines. The formula for the Balmer series is 1 over lambda equals r times 1 over 2 squared minus 1 over n squared. Here, r is the Rydberg constant. It is 1.097 times 10 to the power of 7 per meter. Understanding the hydrogen spectrum is essential for understanding atomic spectra. This is frequently tested. Now, let me explain the Rydberg formula. The Rydberg formula is a general formula for atomic spectra. It gives the wavelengths of the spectral lines. The formula is 1 over lambda equals r times 1 over n subscript 1 squared minus 1 over n subscript 2 squared. Here, lambda is the wavelength. R is the Rydberg constant. N subscript 1 is the lower energy level. N subscript 2 is the higher energy level. This formula applies to hydrogen. It was derived empirically. It was later explained by the Bohr model. The Rydberg constant is 1.097 times 10 to the power of 7 per meter. Understanding the Rydberg formula is essential for calculating wavelengths. This is a common calculation in your examinations. Now let me explain ionization energy. Ionization energy is the minimum energy required to remove an electron completely from an atom. It is the energy needed to take an electron from the ground state to infinity. For hydrogen, the ionization energy is 13.6 electron volts. This is the energy required to remove the electron from n equals 1 to n equals infinity. The ionization energy increases with the nuclear charge. It decreases with the size of the atom. Ionization energy is a key property of elements. Understanding ionization energy is essential for understanding chemical reactions. This is frequently tested in chemistry and physics. Now let me explain excitation energy. Excitation energy is the energy required to move an electron from a lower energy level to a higher energy level. It is the energy needed to excite the atom. For example, the excitation energy to move an electron from n equals 1 to n equals 2 in hydrogen is 10.2 electron volts. This is calculated from the energy difference. The excitation energy is less than the ionization energy. When an electron is excited, it can return to its ground state. It will emit a photon. The energy of the photon equals the excitation energy. Understanding excitation energy is essential for understanding atomic transitions. This is a key concept. Now, let me explain the quantum mechanical model. The quantum mechanical model is the modern model of the atom. It was developed by Schrödinger and others. It uses wave functions to describe electrons. The wave function is a mathematical function. It gives the probability of finding an electron at a certain position. This model does not have fixed orbits. Instead, it has orbitals. Orbitals are regions of space where the probability of finding an electron is high. They have different shapes. The s orbital is spherical. The p orbital is dumbbell-shaped. The d orbital is more complex. The quantum mechanical model is more accurate than the Bohr model. It explains the behavior of all atoms. Understanding the quantum mechanical model is essential for understanding modern physics. This is the foundation of quantum chemistry. Now let me explain quantum numbers. Quantum numbers describe the properties of electrons in an atom. There are 4 quantum numbers. The first is the principal quantum number, n. It describes the energy level. It can be 1, 2, 3, and so on. The second is the azimuthal quantum number, L. It describes the shape of the orbital. It can be 0, 1, 2, up to n-1. The third is the magnetic quantum number, M, subscript L. It describes the orientation of the orbital. It can be negative L to positive L. The fourth is the spin quantum number, M subscript S. It describes the spin of the electron. It can be plus 1/2 or minus 1/2. Understanding quantum numbers is essential for understanding electron configuration. This is a key concept in quantum physics. Now let me explain the applications of atomic structure. Atomic structure has many applications. In spectroscopy, atomic spectra are used to identify elements. This is used in astronomy to study stars and galaxies. In chemistry, atomic structure is used to understand chemical bonding and reactions. In medicine, atomic structure is used in imaging techniques like MRI. In technology, atomic structure is used in semiconductors and lasers. In energy, atomic structure is used in nuclear power and solar cells. Understanding the applications of atomic structure is essential for understanding modern science. This is a key topic in physics. Now, let me explain the importance of atomic structure. Atomic structure is important for several reasons. First, it explains the behavior of matter. It explains why elements have different properties. Second, it explains chemical bonding. It explains how atoms combine to form molecules. Third, it explains atomic spectra.
It explains why each element has a unique spectrum.
Fourth, it is essential for understanding nuclear physics. It explains the structure of the nucleus. Fifth, it is the foundation of modern technology. It is used in electronics, medicine, and energy. Understanding atomic structure is essential for physics and chemistry. It is fundamental to all of science. Now, let me give you sample exam questions to prepare you for your test. State the Bohr model of the atom. The Bohr model states that electrons orbit the nucleus in fixed energy levels. What are energy levels? Energy levels are fixed orbits where electrons revolve around the nucleus. State the formula for the energy of an electron in a hydrogen atom. E subscript n equals negative 13.6 electron volts divided by n squared. State the Rydberg formula. 1 over lambda equals r times 1 over n subscript 1 squared minus 1 over n subscript 2 squared. Define ionization energy. Ionization energy is the minimum energy required to remove an electron completely from an atom. Define excitation energy. Excitation energy is the energy required to move an electron from a lower energy level to a higher energy level. State the 4 quantum numbers: the principal quantum number, the azimuthal quantum number, the magnetic quantum number, and the spin quantum number. Explain the difference between the Bohr model and the quantum mechanical model. The Bohr model has fixed orbits. The quantum mechanical model has probability clouds called orbitals. Let me summarize everything we have covered today. Atomic structure refers to the arrangement of particles in an atom. The Bohr model states that electrons orbit the nucleus in fixed energy levels. Energy levels are fixed orbits. Electrons can jump between levels, emitting or absorbing energy. Atomic spectra are the patterns of light emitted or absorbed by atoms. The hydrogen spectrum has several series. The Rydberg formula gives the wavelengths of spectral lines. Ionization energy is the energy to remove an electron. Excitation energy is the energy to move an electron to a higher level. The quantum mechanical model uses wave functions and orbitals. Quantum numbers describe the properties of electrons. Understanding atomic structure is essential for physics and chemistry. This is Topic 6 in your SS3 Physics series. Study it well. It often appears in your examinations. Well done.